You've watched 10 different YouTube tutorials, half finished 3 boot camps, and you still don't know what to learn next. That is normal. The data world feels like a sea of tools and skills, and without direction, you will easily drown. Let's fix that right now. Over 1 million learners enrolled in data engineering courses on Udemy in 2024, but most never finished, or they finished without building anything. Stick around to the end, and I'm going to show you how to turn them into a full portfolio of the Complete SQL Bootcamp. SQL is where every data engineer begins. It's your shovel. Nothing moves without it. You're going to master filtering, join, subqueries, and window functions while learning to think in sets instead of rows. The interview question that I want you to master while watching this video is, how do you identify and fix duplicate records using SQL? If you can explain multiple approaches like grouping, window functions, and CTEs, you're instantly more hireable than the guy sitting beside you. The project that I want you to practice after you're done with this is recreate a small e-commerce analytics database, load up your mock order, customer, and product tables. Then you're going to write some queries to calculate total sales, repeat customers, and your top projects. Now, you're going to document that like you'd present it to a stakeholder. Your pro tip here is redo each exercise from memory. That is when you start thinking like a real engineer. Once you can query confidently, you're going to hit a wall, and that wall is performance. The next step is learning how to process huge data sets efficiently, and that starts with Python and Spark. Python Essentials for Data Engineers on Databricks. This course takes your Python skills and supercharges them with Spark. You're going to learn distributed processing, data frames, and transformations that actually run on clusters, not just in Jupyter notebooks. It also shows how Spark fits inside of Databricks workflows and how to optimize for performance. The interview question that you're going to be able to master here is, what's the difference between a wide and narrow transformation in Spark? And why does it matter for performance? If you can walk through the shuffle process cleanly, you're going to impress any technical interviewer. The project to practice here is spin up the free Databricks edition, grab the public data set that's already inside there, something like the New York City taxi dataset, and build a PySpark job that aggregates your trips by day and by zone. Be sure that you're going to use Delta format to store those results, and you're going to query them with some Spark SQL. The pro tip here, focus on understanding lazy evaluation and transformation. That is where most beginners get tripped up. They can't explain that clearly or really understand that concept. Now that you've learned how to process massive data sets, it's time to organize and govern them like a pro. And that's where Databricks really shines. So you're going to study for the Databricks Data Engineer Associate exam. This one is your gateway to the modern Lakehouse. It covers Delta Lake, Unity Catalog, and Medallion architecture, which is the backbone of enterprise data systems. You're going to practice ingesting raw data, enforcing schema, and applying governance without killing performance. The interview question you're going to be able to master here is, what is the Medallion architecture and how does Delta Lake enforce data reliability across its layers? Being able to break down bronze, silver, and gold layers shows that you understand systems, not just the syntax. The project I want you to practice afterwards is build your own mini Medallion pipeline. You're going to ingest data into your bronze layer by ingesting raw CSVs from a mock sales system. You're going to create your silver layer, which is your cleaned and standardized data. And finally, you're going to create your gold layer, which is your aggregated sales dashboards that you're going to query using Databricks, either PySpark or SQL. So your pro tip here is, again, use that free community edition workspace so that you could create your clusters, tables, and pipelines all while following along with this tutorial. Now, once you understand how to structure data in Databricks, your next challenge is automating how all that data flows. So let's jump into Airflow and ETL design. Now, with this tutorial, build ETL data pipelines with Python, Airflow, and Spark. Here is where theory turns into automation. You're going to design and schedule pipelines that extract, transform, and load data using Airflow and Spark. You'll finally understand what orchestration means, controlling dependencies, using retries, and what data freshness is. The interview question you're going to be able to master here is, how would you design a data pipeline to handle late arriving data or upstream failures? The question weeds out people who just know Airflow from those who really understand why it's needed. Your project I want you to practice: deploy Airflow locally or in a Docker container. Build a simple daily DAG that loads your CSV data, transforms it with PySpark, and then stores it in Delta. Add one sensor and one failure alert, and that's enough to show that you understand orchestration flow. Your pro tip here: rename tables, change logic, and add logging. Make the project your own. With pipelines running smoothly, it's time to connect all the dots all together. Ingestion, transformation, streaming, and delivery. That is what the next course does, and it'll turn everything that you've learned into a full production system. The ultimate hands-on data engineering tutorial. Now, if I could only pick one, this is the one that I would take. You're going to build end-to-end pipelines with Spark, Kafka, Airflow, and AWS, seeing exactly how data moves from raw to when mentees finish this, they're ready for interviews, ready for real data systems. The interview question you're going to master by watching this is: describe how you design a real-time data pipeline using Kafka and Spark streaming. If you can outline ingestion, transformation, and checkpointing, you're going to instantly stand out amongst the crowd. The project I want you to practice when you're done with this: recreate one of the course's core pipelines, then extend it. Ingest mock streaming data, Twitter, IoT, or some logs out there. Process it in Spark, write it to S3 or ADLS, and visualize the results in Power BI or Tableau. Your pro tip here: document everything that you build. Screenshots, notes, README files. That is your first portfolio asset that's going to win you a job. Here's the bonus for those of you that stuck around. You need to start looking at AI engineering as your transformation from data engineering and stay on the cutting edge of your career. So jump into this course, the AI Engineer course, the Complete AI Engineer Roadmap. Integrate your Python skills with AI. It is going to leverage LangChain for seamless development of AI-driven applications by chaining interoperable components. You're going to use APIs to connect to powerful foundation models, and you are going to utilize transformers for advanced speech-to-text recognition. So be sure you jump on that course as well as a bonus after you get done with these. And I would love to hear about your use cases and the actual projects that you create integrating AI with your data engineering skills that you are evolving into right now. Now, you can find all the course links below. They're affiliate links, so that supports the channel and it keeps these videos free. And once you've mastered these 5 courses, you'll have the exact skills to build your first full-scale data project from scratch. I'll walk you through that step by step in this video right here: how to build your first data engineering project in 30 days. Watch that video to take everything that you've learned and actually put it into practice.